Chapter 2 in class exercise 3. In this in-class exercise, we will learn how to represent a vector as a 3D Cartesian vector and how to find coordinate direction angles for that vector. These angles are alpha, beta, and gamma respectively. So we have two vectors here, f1 and f2, and their angle, they are being represented as shown in the figure. Positive x-axis is this, positive y-axis is here, and positive z-axis is up. Now, vector f1 makes 30-degree angle with xy plane. So this angle is with xy plane. So when we write 80 and close this angle, cosine 30, it will give us the xy projection of the vector. So this length here, that is 80 cosine 30. But when we write 80 sine 30, we are projecting this vector on z-axis. So that will give us the z projection of the vector. So this is 80 sine 30. Now to find the x and y projection, we need to further project this vector onto x-axis using the second angle, which is 40 degrees. So 80 cosine 30 and multiplied with cosine 40 gives us the x projection. So 80 cosine 30 multiplied by cosine 40 is the x projection, while the y projection will be in the negative direction because positive y is here. That will be 80 cosine 30 and sine of this angle. That will give us the y projection. So this is the y projection, and that is 80 cosine 30 sine 30 multiplied by sine 30. Okay, so we have three components of this vector: ith component, which is this number; yth component, which is jth component, which is this number, but it is in the negative direction; and kth component or z projection is in positive direction, and that is this number. So let's write down this vector as a 3D Cartesian vector. F1 is equal to 80 cosine 30 cosine 40 I minus 80 cosine 30 sine 30 j plus 80 sine 30 k. And the unit is pound here, so we will write pound. And when you do this multiplications, we'll get 53.1 I minus 44.5 J plus 40K. So these are three components of the force: F1 x component of the force, y component of the force, and z component of the force, multiplied with appropriate directions. Now to calculate the coordinate direction angle, if you read the question, it says calculate the coordinate direction angles. That means what angles this force makes with x, y, and z axis. So it's looking for the angle that it makes with x-axis, which is alpha 1, the angle that it makes with y-axis, which is beta 1, and the angle that it makes with z-axis, which is gamma 1. So alpha, beta, and gamma can be calculated, and the magnitude of this force is 80 pounds, which is given already. So now to find alpha, we need to apply this equation: cosine inverse of x component divided by f1, which is cosine inverse 53.1 divided by 80, and the angle that we get is 48.4 degrees. Same applies to second angle beta, but this is cosine inverse y divided by f1, and y is minus 44.5, so cosine inverse minus 44.5 divided by 80 and that's 124 degrees. And gamma is cosine inverse z divided by f1, which is cosine inverse 40 divided by 80, and that is 60 degrees. Yeah, so these are three coordinate direction angles for f1. We need to apply the same strategy for f2. So for f2, I'll write the Cartesian representation, which is much more easy because f2 is directly along negative z-axis. It does not have any I and j component, so it is 0i plus 0j minus 130k. Negative sign because the vector k is negative, it's going in the negative direction. Pound. And the magnitude of f2 is 130 pound. Now you can do the same thing. You apply similar equations here for f2 and calculate. Let's label them alpha 1, beta 1, and gamma 1. So this will be alpha 2, beta 2, and gamma 2. Okay, you can calculate in the same fashion. Just 0 divided by 130, 0 divided by 130, and minus 130 divided by minus 130. So you can pause the video and try to calculate this angle yourself. The correct answers are 90 degrees, 90 degrees, and 180 degrees. That's it. Now we can work on the second problem for that in class exercise, which is problem number 2.72. Two forces F1 and F2 act on the screw I. If the resultant force Fr has magnitude of 150 pounds, so resultant force of these two forces, which is this force, is 150 pounds, and the coordinate direction angles are shown. So for Fr, resultant force, we know the angle alpha, which is 120. We know angle beta, which is 130. We do not know angle gamma. So we need to determine that. Determine the magnitude of F2 and its coordinate direction angle. So we need to calculate everything for force F2. Okay, so let's work on this problem. So first thing we need to do is we need to calculate the value of gamma. Now, how do we find the gamma? So we have studied this equation that cosine square alpha plus cosine square beta plus cosine square gamma is always 1. Now we know the values of alpha and beta, so we can substitute that here into this equation and calculate the value of gamma. So I give you a time to calculate this, and then you can compare your answer with my answer. Okay, so there are two possible values of gamma. One of them, because it's cosine square gamma, so one of them will be more than 90 degree, but by looking at this graph, we can see that the gamma is less than 90 degrees. So we will consider the value of gamma as 54.52 degrees. Okay, so that is step number 1. Now step number 2 is we write down the resultant force as a Cartesian vector, Fr. So Fr can be written as the magnitude multiplied by, so Fr magnitude multiplied by unit vector for resultant force. And unit vector can be written as alpha, beta, and gamma. So this can be written as cosine alpha I plus cosine beta j plus cosine gamma k, where magnitude of the vector is given, it's 150 pound, and now we know the values of alpha, beta, and gamma. So this is cosine 120i plus cosine 130j plus cosine 54.52k. Okay, so we can write this, and when we multiply 150 with each one of this component individually and make sure that I, j, k components are separate, we get minus 75i plus 96.42 J plus 87.05 K, and we get this resultant force in power, Fr. Now we can write F1 as a Cartesian vector, which is very simple. It's along y direction only, so it can be written as 0I plus 80J plus 0K pound. And the resultant force and the third force, missing force F2, we can simply calculate by combining F1 and Fr. So Fr is combination of F1 plus F2. So F2 is Fr minus F1. So what we will do is we will change this sign to minus 80, and then we will subtract its component from the Fr. So resultant force F2 is then minus 75I. Then it is 96.42 minus 80 because we have a negative sign here. So that will be 16.42 J, and third one is 87.05 K pound. Now once we have this vector, like we can calculate its magnitude and direction cosine. So we can calculate the magnitude of F2 by square root of 3 component square, that is 75 square plus 16.42 square plus 87.05 square. And that is 116 pound. And then we can calculate angles alpha 2, beta 2 and gamma 2 by cosine inverse of x component of F2, which is minus 75 divided by its magnitude 116. So that angle is 130 degrees. And same thing you can apply to remaining two angles, but just change the cosine 16.42 divided by 116 and cosine inverse 87.02 divided by 116 and calculate the remaining two angles. You can pause the video and try to calculate this yourself.